Hello everyone, we've got question 8 here, and it's a nice trigonometric proof one. Now again, what I would say with this one is there are so many ways of doing this, so I've just done the way that just occurred to me first, but there's probably about 5 or 6 different ways, and they're all probably equivalent. So if you get a different method that you would totally prefer to do it and it's different, then that's absolutely fine. So question 8, it says prove that 1 over cosec minus 1 plus 1 over cosec plus 1 is equal to 2 tan theta sec theta. So the preferred method with this is to start off with one side, either the left hand side or the right hand side. And I think in this case, as we've got like adding, we're going to start off with the left hand side, and we're going to go step by step by step and show that we end up at the right hand side. So how have I chosen to do this? So first of all, I've written the left hand side out, and I've said to myself, cosec is 1 over sine. So I've just replaced that with 1 over sine. And straight away, that's looking really horrible. Whenever you've got this kind of scenario where you have like a fraction within a fraction, the way to deal with it is to multiply the numerator and the denominator by the thing that's causing it to be a fraction within a fraction. So what I've done, so just to illustrate with this first one, is if you multiply the numerator and denominator by this, then it gets rid of this inconvenient fraction within a fraction. And you can see that this becomes sine over 1 add sine theta. And I've done the same thing with this other one. I've multiplied the numerator and denominator by sine theta like that. Okay, so that gets us to this stage here now. Well, that looks a little bit better. So let's just try and combine this over a common denominator and see if that makes life more straightforward. So I've multiplied now the numerator and denominator of this one by 1 add sine theta, and I've multiplied the numerator and denominator of this one by 1 minus sine theta. So that gives me this expression now. Sine theta times 1 add sine theta times 1 minus sine theta. I've combined the whole thing over one fraction and expanded the brackets. So I've got sine theta plus sine squared plus sine theta minus sine squared. So now my sine squareds are going to cancel because one's positive and one is negative. And I've got sine theta add sine theta gives me 2 lots of sine theta. So this is now starting to look a lot better now. So we've got 2 sine theta over cos squared. We can see that we're aiming for 2 tan theta sec theta. So what I've done there is I've now said that sine over cos is going to be tan, and then we've still got 1 over cos. So 1 over cos is sec, so we've now got 2 tan theta sec theta. So we've actually got what we were after. So that is our part A done there for 3 marks. Part B, hence solve x, for x is 90 to 0, the equation 1 over cosec 2x minus 1 add 1 over cosec 2x add 1 equals cot 2x sec 2x. So what we've always got to do in these questions is look for the link that connects the part A and the part B. Okay, so we're looking for the link connecting the 2 parts. And let's draw our comparison. So we've got here theta, and in this other equation we've got 2x. And over here we've got theta and we've got 2x. So in essence, we've got the same kind of connection. It's just the theta has been replaced by 2x. Sometimes they make it more awkward to see what the connection is, but that's quite a nice one. So just theta has been replaced by 2x. So what else are we going to use? Well, we're going to use the fact that in part A, we found out that this expression is 2 tan theta sec theta. So we can say that 2 tan x sec 2x, 2 tan 2x sec 2x is equal to cot 2x sec 2x. So we've just used the result from part A to replace the left-hand side. Okay, so now it's time to solve this. So let's have a think about what we're going to do here. So, well, the first thing is cot is 1 over tan. So I've replaced cot with 1 over tan there. Then I've multiplied everything by tan. So I've now got 2 tan squared 2x sec 2x is equal to sec theta. Now, at this point, you might be wondering, this is like, some people might be thinking, why couldn't I cancel out a sec 2x? Because I've got a sec 2x there and a sec 2x there. Now, the reason that you cannot cancel those out is because you would lose the solutions that are going to come from sec2x. So what you need to do is you need to take the whole thing over to one side and factorize out the sec2x, okay? Very, very, very important thing there. So you're not losing the solutions that come from the sec2x. So you take the whole thing over to one side, and as I just said a moment ago, you factorize out the common factor of sec2x. So this is looking quite nice now. So we've got our 2 tan squared x minus 1 and sec2x. Let's do the sec2x first. What does our graph of sec2x look like? Well, sec is 1 over cos. So I don't remember what sec looks like, but I do remember what cos looks like. So I just draw my cosine graph like that. And I know that sec is 1 over it. So sec is going to be looking like this, and like this, and like this. So in other words, there are no solutions to sec 2x in between 1 and minus 1. So in between 1 and minus 1, there are no solutions. So no solutions are going to come from sec 2x equals 0. So let's turn our attention now to tan squared 2x equals a half. We need to square root that. So, and do remember that we need to have plus or minus when we square root. The second thing is we need to adjust the domain because we've got that x is less than 90 but greater than 0. However, we're dealing with 2x, so we need to make an appropriate adjustment to the domain. So we need to double it. So we're looking for solutions in the range 180 to 0. Okay, so we're going to do, let's deal with the positive 1 over root 2 first. So inverse tan of 1 over root 2 gives us 35.26. So that's one of our values, okay? And I can see that if I added another 180, I'm going to go over the limit. So, and if I took off another 180, I'm going to be outside the limit there. So that's the only solution that's coming from 1 over root 2. So I just divide that by 2, and that gives me 17.6. Now let's turn our attention to the minus 1 over root 2. So inverse tan of minus 1 over root 2 is minus 35.264. I add 180 to it to get to the next solution, and that gives me 144.734. So that's our other solution. And then we divide that by 2 to get our x, and that gives us that solution. And those are the only two solutions that are going to be within that range. Quite a nice, getting a bit more challenging now, 7-mark question on trig identity, reciprocal trig identities. I hope you found that helpful, and I'll see you in the next video.